All right. Okay. Well, we'll begin. And how's everybody doing? Happy Friday. First week. First week down. 9 more to go.
Or 10 more to go.
And then, well, I guess 9 plus finals, but just 9, right? Okay. And then you're graduating.
Yay!
Yes, we're excited. And then you have the rest of your life and everything. Okay.
That's not intimidating.
Let's all right, so we covered Git, we covered GitHub. Did anyone find a friend and try to access each other's repositories? No. Okay.
We're still in the setup phase.
There's no way for me to check this, but you're gonna have to do this eventually, okay? One thing you got to do is if you want somebody else, you have to invite them as a collaborator to your repository. So, you say, "What's your username?" and they go, "Oh, I'm blah blah blah," and you add them as a collaborator, and then they can push to your repository. One thing though is that if somebody else creates a branch, so just read these links, okay? I've added these links, but if somebody creates a branch, normally if you do a pull, it just pulls kind of the branches that are on your machine and on the repository. And if somebody else that is collaborating has created a new branch, then you have to fetch that branch. So you do a git fetch, and it pulls down basically all the branches on there. Okay. Here, I'll draw a little diagram, right? So, wait, something's wrong with my pen again. So I fix this up. Okay, well, the short of it is read those links that I've posted, and you should be okay. All right? But basically, if you've got your remote repository, you're going to have your master branch, and then, maybe your branch, and then you have a collaborator branch. And then on your local machine, you've got master and you have your branch. Now, when you do a git pull, it will update, it will sync the branches that exist, right? But somebody else, your collaborator, has created a branch and pushed that to the remote repository. If you want to get that, then you do a git fetch, and then it will pull the collaborator's branch into your local repository. Okay, so that's all. Okay. At some point, we'll have a group project, and you'll be doing everything on GitHub, right? I mean, that's the hope. Okay, is that you will be collaborating together on GitHub, and so you'll get practice with pushing and pulling and fetching, and kind of working with someone else.
Is fetching only if you're pulling a collaborator's branch?
Fetching will pull basically all the branches that exist up in your repository, whether they are currently on your machine or not.
So it's like pull all, kind of?
Kind of like that, yeah.
So if you just do git pull, it won't pull the ones.
Git pull will pull the ones that are on your local. It'll sync your local repository's branches to the remote repository.
But not the ones that were collabed.
But not the ones that have been added by a collaborator. Okay. The Git branching can get quite complex. I've added an optional link here. If you want to delve a little bit deeper into all of that, you don't have to. Okay. On Monday we'll have a short quiz on Git. Okay. It'll be short if you got through the data camp tutorial and understand kind of your general basic commands, it should be fine. It's intended to be on the easier side as long as you've done your homework type of thing, okay? And it'll be quick. Okay, let's talk about getting a Python onto your machine, okay? I'll post a link, but we're going to use Anaconda. Okay, so you can just search. Oh, okay.
Well,
All right.
oops.
All right, so the Nicki Minaj's video is the #1 thing, but anaconda.org is the thing that we're going for, okay? And so you'll search for Anaconda, and then you'll go over to download Anaconda, and then you will get the Python 3.6 for whatever computer you have, okay? And then you'll install that, okay? It should be pretty easy. The reason why, so let me just kind of explain the idea of Anaconda is that you can go to Python's website and just get Python, and you'll get the Python interpreter and all of that. But people have been kind of building things that interact with Python and do other stuff. And so in particular, there's a customized version of the Python interpreter called Ipython, and then there's something called Notebook, which allows you to make notebooks, and so Anaconda or Conda is kind of this system that allows you to install all these things and allows you to update these different things kind of from one place, rather than having to have these separate. They are still separate programs, but there's kind of this base that you can update, where you can update these things. And so so that's what we're using. Anaconda is kind of the I don't know. It's the nice wrapper for the Conda interface, and so you'll download the thing, and you will install it, and I think it defaults to installing Notebook and Ipython and Spider. Spider's kind of like a RStudio IDE, and when you launch Anaconda Navigator, it will, takes a little bit, but it'll look kind of like this. And so I think it'll come, I guess Jupyter Lab, Notebook, Jupyter Notebook, Ipython, the Qt console, and Spider, okay? And then, an important thing is to keep your packages updated and things like that. And so if you want to do run updates, you'll use Conda, which is the kind of the terminal command that we use here, okay? And so after you do that, you can go into your environments, and you can start like open a terminal. You can open your terminal on Mac as well, okay? So on Windows, it'll be either your CMD or maybe your so here, let's see if yes, I think I recently updated a bunch of packages, but let's say I want to update package bokeh. All right, so I would do Conda. Oh shoot, I'm forgetting my things. Okay, update. Did I just type in bokeh? Oh shoot. Okay, I hope this is what we want. All right, so it always kind of does this thing, and it tries to figure out what dependencies we have, and I should just double check. Okay, so here I told it I want to update the package, or the package bokeh, and it says basically you currently have 0.12.10, and it will be updated to 0.12.15. Okay, and it says, do you want to proceed? I'm going to hit yes, and then it downloads and installs it, and it takes a little bit of time. You can do conda update -all, and it will do everything, but it might take a long time, and sometimes the package updates conflict with each other, and it can not always. It's possible that it doesn't work. Okay, so the nice thing about conda is that it allows you to update not just Python packages, and so here it says bokeh, and then if I click update index in the Anaconda navigator, this should update from 0.12.10 to 0.12.15, and it's now in black and white, indicating that it's up to the latest version. You'll see this little blue arrow indicating that an update is available. Okay, but this it used to be you would use something called pip. A pip was the kind of the Python package installer, but conda now allows you to use it. You can use conda to update your Python packages, and you can use conda to also update things that aren't Python packages, like Notebook, which is this separate thing that runs to allows you to create these Python notebooks. Okay, and so yeah, basically you'll just most of the time you'll do conda update whatever the package name, and if you see a package that you want to install, so you can go over to the list not installed, and I don't know, there might be something that you want. You can do conda install, and you type in the name of the thing that you want to install. Okay, and generally you'll do this from the kind of your terminal here. All right, is that okay? And so I would recommend, at least on a weekly basis, go kind of check and see if updates, because pretty much a lot of these Python things are like open source, and so they're constantly being updated by the community, and you generally want to stay up to date on a lot of these things, especially the ones that you use frequently, like NumPy and Matplotlib and all of these things, or Notebook. Whenever there's updates, you'll want to do a conda update Notebook type of thing, and some of the updates will take longer than others. Okay, so you get your Anaconda installed, you update your packages, things like that. We will look at Jupyter and Ipython, and I guess we could even look at Spider, but probably we will be doing most of our work with Jupyter notebooks. Okay, and so you can from the Anaconda navigator, you can type in, you can just click this button, launch. Okay, or you can also if I kind of close that down, you can also start from the terminal. Oops. I don't know what's going on here. So if I launch my command prompt, I can just do Jupyter space notebook. Wait. Okay, am I doing this wrong? All right. I'm just going to click the launch here, but you should also be able to launch the notebook just from the terminal, but I didn't do it. Okay, so this starts up, and here I'll work in my 131 directory. I'll navigate to here, and I'll go to my class demo repository. And here I'll go ahead and I'll do a new Python 3 notebook. Okay, and here I now have this is a blank Python 3 notebook, and this is running on my local host server. Okay, so it runs in your web browser, and your web browser talks to basically a web server, and most of the time you go and it finds Google's web server, and Google's thing sends you your web browser stuff. Basically, when you run Notebook, Notebook sets up a local web server called localhost, and it's acting as a web server that your browser can interact with, and you produce stuff, and your local web server will take it and feed back, produce whatever it is that you want to make here. Okay, so here all I did was I said, create a new Python notebook. So I will call this class demo. All right, so this is my class demo notebook, and it's going to have it uses basically the Ipython interpreter here, and it's a little bit kind of like when you create a R Markdown file, except it's interactive. And so in R, so I'm talking to everybody here as if like you guys have these R and RStudio background things, right? Because this is kind of where we're probably familiar with. So in RStudio, R Markdown, you write your things, you write your code chunks, you write your Markdown, and then at the end you click knit, and it knits everything up, okay? Or, recently they updated the thing so you can click the little play button in the corner and it will run that chunk of code. Pretty much here you're writing these code chunks and these things, and it will run each code chunk, okay? I think I've posted a thing of keyboard shortcuts for Jupyter Notebook, okay? And so I definitely, in the beginning, I recommend everybody, I'll post a bunch of cheat sheets, and you should download all of these cheat sheets and work to memorize a lot of these commands, okay? This goes, anytime you learn a new language, whether it be a foreign language or computer language, there's two things you've got to learn. One is the grammar, or the, kind of the structure, and the other is the vocabulary, okay? As far as Python grammar goes, it being an interpreted language, it is fairly easy, I think, to transition from R's grammar and language structure to Python's grammar and language structure. There's a lot of kind of corresponding things and, vectorized operations, and it being an interpreted language, you don't have to define variables as integer types, and it coerces stuff. And so the learning the grammar of Python for an R user, someone coming from R, is probably not too bad. The hardest part is probably going to be learning the vocabulary, okay? And so, all of your, like a few words, you have, some cognates like print and things like that, but many of the other ones, you've got to learn new vocabulary. So we'll start off with I'll post some cheat sheets and things like that. Okay, so here is your Python notebook, and you can just give it your first command, which could be like, what is 1 plus 2? And then to run it, you hit Control Enter, and this will run the command, and it says, okay, input 1 is 1 plus 2, output is 3. No surprise there, right? Okay, so after you run it, if you want to insert a new cell below the current one, you hit B. If you want to insert a new cell above it, you can hit A. Or if you forget the keyboard shortcuts, you can just click a button here. This is the plus, and this will say insert a cell below, okay? So I can hit B on the keyboard, and that does it. If I hit this, it will also insert the cell here, okay? you are in command mode when the this thing on the side is blue, okay? And you can use your up and down arrow keys to kind of go from cell to cell. You can also use the J and K buttons on your keyboard, so you don't have to even move your hands from the home row, and you can go up and down from cell to cell. So let's say I say, oh, I want to go back to this cell and I want to edit what's inside here. I can just hit enter. I go into that cell and I say, you know what, forget 1 plus 2, we're going to do 1 plus 2 plus 5, okay? And then Control Enter will run that. If you want to run it and then automatically move to the next cell, you can hit Shift Enter, okay? Shift Enter, it runs it, it returns 8, and it automatically moves me to my next cell. You'll notice that the in and the out have updated to say into and out to. This is basically telling, reporting back that this is the second request that I made of Python, and this is the second output it has done to the screen. And because we put it in the same cell that used to be there, it's there now. Okay, so let's say I want to do something into this cell. So I'm going to hit enter to enter that cell, and I'll create a variable called n, and this will be we will say n is hello exclamation point, okay, and then I will hit enter. Enter just allows you to write more lines in that thing, and I can say print n, okay, and we can also do print n times 4, okay? And so this might feel a little bit funny for those of us in R because we see a string and I'm saying string times 4, okay? And you're like, what's it gonna do? Okay, well let's take a look, all right? So I'm gonna go ahead and I'm gonna just hit Shift Enter to run this code, and it will move on to the next cell. So I hit Shift Enter, it prints out hello, and then when you do, if you give it a string and multiplication, it just repeats out the string however many times you give it, okay? So you can do that. If you do a plus, it concatenates. So if I say, if I come in here and I say J is equal to miles, okay, then I can do print n plus j, and we don't it will not have a space here, but I can just hit Control Enter, and it will it just concatenates the two, okay? So it kind of does a paste there. So so Python allows you to do kind of these addition and multiplication operators with strings, okay, which is kind of fun, okay. So all right, we want to insert a cell here, and you know there's a whole bunch of things, and so here I guess we'll start with some string operators, of which there are many, okay. And so let's see, we can do s enter here, and I can do s dot, or not s, I will take the string, n is currently a string, and I can hit n dot upper, and if I'm gonna go just hit Shift Enter, it turns everything in there to uppercase, okay. So Python is a object-oriented system using message passing object-oriented. So it's not a generic function. R is a generic function thing. So you use all sorts of, have the same function, and each function has different methods. Here the objects have the methods assigned to them. And so we have different different methods for our objects. And so n is a string, so all strings come with the upper being an uppercase method, and it will turn the whatever we have to uppercase. Here, let me zoom in a little bit. Maybe that's better. Okay, we have a few different types, okay, of data. So one is an integer. So if I can do type, and you give it a number, okay, it'll say that's an integer. Oops, yeah, the wrong thing. Okay, if I do type 4.0, okay, this will be a float. Okay. And the nice thing about Python is you will always know if you've got an integer or a float, because if it's a float, it will always show at least a decimal. So even if there's nothing after it, it will be a decimal. So for example, if you do 10 times 1, okay, and I have that, and I do 10 divided by 1. Oops. Sorry. Let me do print 10 times 1 and print 10 divided by 1. Okay. The first one, an integer times an integer, 10 times 1 will produce an integer, and you will know it's an integer because it will come back with just 10. Okay. 10 divided by 1, anytime you do division, it will always produce a float. Okay, even if it comes back a whole number, it will always be a type float, and you know it's a float because it will say 10.0. Okay, whereas this was something that was ambiguous in R. You didn't really, like, just seeing a number, you didn't know if it was type integer or type double. And so here we call it type float for integer. For the double precision things, okay? And then you still have booleans and character things, okay? One thing to get used to is the booleans are spelled with the first thing capital and everything else lowercase. So you have type, so this will be true. Okay, and that will obviously be a Boolean. Whereas if I did type true, it will get confused. It will say this is nothing. This doesn't exist. Okay. And then the null object is type none. Okay, none is the null object, and it comes back as none type. All right, let me show you something that I think is kind of neat. So we're gonna so I think it auto saves, and we're gonna go ahead and do close and halt. Okay, so when you run a notebook, it creates this kind of this Python kernel that's running in the background, and it's using up system resources. And so if I just close it, you'll see under running the notebooks, it will say class demo.ipython notebook. Okay, so this means all of this stuff is still running. Here I will go ahead and do close and halt, and then it will tell us that no notebooks are running. Okay. Let me go to my class demo repository here, and so we have the class demo.ipython notebook. I'm going to go ahead and open Git here, and I hope this works here. Okay, I'm just gonna go straight to the master repository. Okay, I know I said don't do this, but we're gonna do it. Hold on. How do I have to keep doing this every single time? I don't know. I'll have to All right, so let's get status and just see. All right, so we want to, I'll go ahead and just add everything, okay? Here it's warning me about LF being line feed. The way Windows and Macs handle the end of a line is a little bit different, okay? There's these secret, basically when you write a text file, when you reach the end of a line, it sends commands. There's carriage return and there's line feed. And in Windows it uses CR and LF together to kind of let the computer know that it's getting a new line, and on the on Unix-based systems it's different, and Git tries to do its best to do it whatever it can. Okay, so I'm going to go ahead and change this, and so git commit m added class demo notebook. Okay, so we'll do that, and then I'm going to push this to my GitHub repository. All right, and we'll go over to GitHub, and Redshirt Prof is my other alter ego, and so I'm on my Smiles Chen class demo repository here. Okay, and so we can see 19 seconds ago I have updated class demo.ipython notebook, and when you open this, now this might not be impressive because you haven't really dealt with GitHub that much, but it produces not the raw file, okay? So the raw notebook file looks like this, okay? And you know, you might have, sometimes on CCLE I'll post an R Markdown file, and when you click it, it'll look just kind of like this plain text thing. And it's not until you download it onto your computer and you render it that you can actually see what the thing is supposed to look like. The neat thing is that on GitHub, it understands how to render these Ipython notebooks, okay? And so it will show up here the way you might expect it to appear. Whereas if you did like a regular old R Markdown file, it will look like this, okay? So if you upload like a R Markdown file, it doesn't look pretty. It just looks like that kind of that raw text. But with Ipython notebooks, it will render out the notebook the way it looked on your machine when you were kind of last running it. Okay, so it's a neat feature. Okay, maybe because I'm just showing you, it just seems like, well, of course it should do that. This is like a more recent feature to more recent being like 3 years ago type of thing. It's a more recent feature to GitHub, and people are quite excited about that. And so basically, what you want to be doing, let me just give you some job advice or career advice, is if you are planning on applying for jobs, you want to build up your GitHub repositories, okay? You want to build up your GitHub as a way to demonstrate your capabilities, okay? Don't, because people who are going to apply for their jobs, their resumes are all going to say proficient in R, proficient in Python, or something like that, right? And in fact, don't use the word proficient in Python, okay? That just, like, everybody says stuff like that, right? And you don't want to say expert in Python if you're not an expert in Python. You want to say something like 100 hours coding experience in Python, or something like that. So, you know, start timing how long you're spending on writing code. And, you know, probably by the end of this class, it'll be like 30 hours of Python coding experience, maybe 50 hours of Python coding experience, depending on how many hours you spend each week. But basically, kind of keep that in mind, and on your resume, put a concrete number, like 100, 200 hours coding, Python coding experience or something, and then have a repository with kind of these notebooks that show what you're capable of doing, right? So it's, I'm gonna have to assign this group project and things like that. Have your notebook show kind of the data analysis that you've done that shows, you know, your reasoning behind everything. And then somebody who's looking doesn't have to just look at your resume, but can actually look at your GitHub and see, oh, this is the type of code that they're capable of writing, right? And if you've got lots of code, good reasoning, this will indicate to them that you're a strong candidate and not just somebody who said, you know, I completed a course in Python, okay? At this point, completing a course in Python is a fairly low bar, okay? You can just go on any website, you know, DataCamp offers it, you know, Coursera, EDX, all of these different things offer courses in Python. And technically, you can just watch the videos for 6 hours or whatever, and then you can say, I've completed a course. That doesn't mean you know how to code. Demonstrate your ability by producing notebooks and posting them on GitHub so people can see what you're capable of, okay? I guess, you know, I won't do this. I feel like the DataCamp homework is enough as it is, but I guess I can kind of list off some ideas for like extra projects that you can do for personal growth, okay? All right, let's go back to our notebook and continue. So under class demo, so you're under week 2, I posted a DataCamp for kind of like your introduction to Python, and you can start working through that, and that'll kind of work you through the base types. Other things in the notebook is you can go from code to Markdown, okay? To switch something to Markdown, you use the letter M for Markdown, and it doesn't look like anything changed, except you'll notice that the Ipython in square bracket thing disappeared. And basically, you would write Markdown code. So if you want to put in like you can make a heading, okay? So this is like the same Markdown that appears in whatever you call it, R Markdown, okay? And you can do let's make a table. Is this how we make a table? I forget. Okay, and then, oh, no, that didn't work. Wait, how do you make a table? I forget. Shoot. Okay, Markdown table. This is embarrassing. Oh, I have to do this. Okay, that's what you need to do. Okay. Yeah. All right. I will just cheat and I will copy and paste this table. Okay? But I wasn't too far off. But I think you have to create the kind of this. Okay, and so here we go. So it makes the table, and it makes the table.
Cool.
And then if you want to go back to edit, you do this. Oh, I think I have to escape the dollar signs because I want to say I can do math. Maybe I can't. I forget. I'm pretty sure I can. Yeah. Okay.
Wow.
So similar things, right? So this is probably, I think. So again, as you're doing your analysis, you don't want to just have code with no commentary, right? Any kind of data analysis requires somebody to be talking through and explaining what exactly we're looking at. So you would say like, okay, we're going to run this kind of. First, we're going to calculate the mean of our vector and whatever, and we see this and that. Okay. Other stuff. So Python uses lists just like many other languages. So we'll define L as a list, and a list can be mixed types. Okay, so we can have Adam and Bob and 30, and that's fine. Okay, so that just produces the list, and then we can just ask print out the list.
Oh, does it automatically take you out of the markdown when you go to the next line, or do you have to like do something?
Okay, so it's just regular markdown now. So if you hit enter, it brings you into editing mode. Okay, and then you can say stuff like this is my second table, and then when you hit Control Enter, it renders the markdown into something visible, right? And you can do that. and to switch from so if you hit B to enter a new thing, it defaults to being a code type thing, and so you would have something like 3. Whoops. What did I just do? Okay, so to switch between code is Y, M is markdown. Okay, so when so I put in while it's selected in command mode with the thing blue, Y will turn it into a code chunk, M will turn it into a markdown chunk. Okay, and then you go in, you hit enter to edit whatever it is that you're doing. Okay, so I can do L dot count. How many times does Adam appear? And it says it appeared 1 time. Okay, not that interesting. I could go back and I can say, you know what? Let's stick Adam in here twice into my list. Okay, and so you can see when you run a thing of code, it doesn't run everything below it or anything like that. Okay, so you can be like, how does count Adam show up 1? Well, that's where these numbers play into part. Okay, because the third request I made was this. We don't actually get to see what happened before, and we can see that the fourth request I made was we're going to define this list L as Adam, Bob, 30, Adam. Okay, and so now if I run this command again, okay, now that this is the 5th thing that's run, and we can see that Adam shows up in the list twice. Okay, again, all of these things, kind of the methods that belong to lists and strings. These are just going to be vocabulary functions that you're going to have to kind of learn along the way. I'll post some cheat sheets that I think are very good for this type of stuff, and your intro to Python and Data Camp will cover a lot of these basic methods and stuff as well. Okay. Do we have more questions at this point? So this is the Jupyter notebook, which is a great thing. I'll just very briefly show. So we'll close that, and we will log out of the notebook there. We'll do git add, git commit updates. Okay, and we'll push. Okay, going back to the navigator. So the Ipython console, this is just going to be kind of a console. Jupyter uses Ipython. So Ipython implements some nice features like tab completion, which isn't available in the base Python interpreter. So tab completion is kind of like you have some variable names, and when you start typing it, you can hit tab, and it will complete out the variable names. And if there's multiple things that start with the same thing, when you hit tab, a little drop down will appear that lets you choose from that. So I can say like name one is oops, that's will be Miles, and then name two will be Joe. Okay, and so if I do N and I hit tab, it gives me, oops, this is not what I wanted. Okay, never mind. I guess not. Okay. Maybe tab completion only works for functions. Okay, well, anyway, so this is the Ipython console. It's handy, and it's a good thing. And then here is Spider. These are other things that are possible. Probably our primary thing will be the Jupyter Notebook in terms of all of this stuff. But you know, if you're trying to write, you know, a medium-sized script, it probably makes sense to just write your script in a text file, and you save it with the .py extension, and then you can run it in the console. But Spider allows you to is kind of just this, you know, integrated development environment IDE that allows you to do stuff. And so here's kind of your script that we're defining over here, and then it runs a console, and we can run this file, and you know, whatever we have going on over here, you can hit the play button and it will show up in the console and run. So this is probably familiar to those using RStudio and things of that nature. And this is you know, recommended for if you're writing standalone scripts. Okay, so I would say, you know, if you're going to do a data analysis thing, I think a notebook makes sense because you can mix up the code with commentary, which is something that is necessary for data analysis. But if you're writing just a straight script, like you're making a quick program, then using something like Spider makes sense. I probably just run two separate things. For me, I use the Ipython Qt console and Notepad++. Notepad++ is kind of my text editor of choice on Windows. You know, there's a whole bunch of text editors out there that you can choose from, Atom and things like that. But and this is also a good choice as well. So there we have that. So this is just kind of the very beginnings of, you know, getting your Anaconda thing installed on your machine and getting Python up and running. So we'll do that, and then we'll delve more into Python on Monday. Okay.